Alright, we're going to find the derivative. F of x equals x cubed plus 2x. Let's see if we remember some stuff. I mean, it's okay looking at your notes a little bit, but as we practice, as we do these, we should be able to wean ourselves off of our notes. Your setup, f prime equals, would that be limit?
Delta x.
Okay. F of x plus delta x minus f of x all over delta x, right? Okay. And then we have limit delta x goes to 0. Again, we don't have to write this step out. We could start substituting x plus delta x into f, but it's nice to set this up to tell us what we need to do, especially in the infancy stages of doing these problems. So we'd have x plus delta x cubed plus 2 times x plus delta x, right? Minus, big parentheses, x cubed plus 2x. Alright, now, hard part is expanding that cubic, right? Two ways to do it. Let's do each way. Limit delta x goes to 0. Little bit of algebra. Should have what? X plus delta x, or x plus h, obviously. So it's going to be 3 factors of x plus delta x. I'm going to put one of them out here, and then I'm going to basically square the other two, right? So it'll be x squared plus 2x delta x plus delta x quantity squared. And then we can distribute here now if we want to. Plus 2x plus 2 delta x minus x cubed minus 2x all over delta x. And now distribute this binomial through this trinomial. So that'd be x cubed. Okay, x times 2x delta x would be 2x squared delta x. X times delta x squared would be x delta x squared. Now distribute the delta x through. X squared delta x. 2x delta x squared. And then plus delta x cubed. And then the rest of this stuff. Minus x cubed minus 2x. Fit it all in. Sweet. Now combine like terms. Alright, looks like for x cubes, I'm just going to go down the row here. Change colors for fun. X cubed, right? 2x, negative 2x. How about 2x squared delta x? Oh, there's another one. So I got 3x squared delta x's. And then I have x delta x squareds. There's 1 here, 2 here, so 3 of those again. And then will it be delta x cubed? And then plus 2 delta x. Now we could have done the advanced move and factor delta x, because we could have noticed that everything left over had a factor of delta x in it, but I didn't want to. Limit delta x. Yeah, my hand isn't sore yet from writing, so I wanted just to write some more and get to that point. So we have what, 3x delta x plus delta x squared plus 2. Cancel delta x's. Lim Alright, let's see here. 3x squared plus 3x delta x plus delta x squared plus 2. Parentheses around everything. Let delta x go to 0. Okay, this does not have a delta x, this term. This term does, so this one goes to 0. This term does, so this goes to 0, right? And what are we left with? 3x squared plus 2. And so that's the derivative, that is f prime. And again, what is the derivative? The derivative is the slopes of all tangent lines along the curve for any x value. We could take this one step further and ask you guys to write the equation of a tangent line, but I think we know how to get the point, right? Questions on this one? Alright, let's find another derivative. Find f prime for f of x equals square root x. The problem continues on by saying find the slopes of the graph of f at the points 1, 1 and 4, 2. Discuss the behavior of f at 0, 0. Okay? So let's see here, f prime. Limit. Let's use h. F of x plus h minus f of x all over h. Okay, limit. H goes to 0. F of x plus h, that would be root x plus h. Minus f of x, well that's this, square root x all over h. What type of limit problem is this? Definitely a conjugate problem, right? Okay, let's multiply by x plus h plus radical x over x plus h plus radical x. X plus h. Okay, that'd be the positive version, the negative version, right? And then negative x all over h times radical x plus h plus radical x. And we're not going to mess around with the denominator. We're not distributing this h through because the h is the problem. We want to try and factor that out. I think you guys can see what's going to happen. X minus x. H over h times. And then we can cancel the h's. And what's left in the numerator then? Yep, 1. Don't forget the 1. The first initial setup. Ooh, what am I doing there? The first initial setup was calculus. It's just been all algebra since, right? And now we're ready for some more calculus. We're going to take the limit. H goes to 0. That goes to 0. So now we have 1 over root x plus root x, which is equal to 1 over 2 root x. Just leave it like that, please. Okay, that would be the derivative, right? So I'm going to go up here so we can see the problem again. I'm going to rewrite the derivative so I can see it and you guys can see it. What is it, 1 over 2 root x? Okay. It says find the slopes of the graph. That means the slope of the tangent line. Remember we noted that a couple days ago. At the points 1, 1 and 4, 2. Okay, 1, 1 is on the graph of f. If you plug in 1, you get 1. If you plug in 4, you get 2, right? Plug in 0, you get 0. So all three of these points are on the graph. They might try and trick us. Okay, just be careful. So if we want to find the slope of the graph at x equals 1, we're finding f prime of 1. Plug in 1. And what is that, 1/2 then? So slope of the tangent line at x equals 1 is 1/2. we could now write an equation of that tangent line. We have slope 1/2, we have the point 1, and we can take this further, right? That's one of the other things they'll ask us to do. But they're not asking now, so I don't want to do it. Now let's find the slope at 4. F prime 4, 1 over 2 radical 4. Root 4 is 2. 2 times 2 is 4, so 1/4. Okay. Coincidentally enough, they gave us square numbers, right? So these problems are kind of easy. If they gave us, let's say, 3, they want us to find f prime 3, 1 over 2 root 3, leave it, you're done. Okay, you can leave these answers non-rationalized, but if the answer choices do show rationalized answer choices, you should know how to rationalize a fraction, right? Okay, questions on this so far? Well, let's find f prime 0 then. Because they kind of asked the question in a different way. Discuss the behavior of f at 0, 0. Well, we know 0, 0 is on the graph, right? Let's plug in 0 to our derivative. That's 1 over what? Which is undefined. So the slope is undefined. What does that mean?
It's vertical.
Vertical what?
The slope is vertical.
The slope is a descriptor of something. It's a vertical what? Tangent line, right? We have a vertical tangent line. Okay, so we have a vertical tangent line at x equals 0. Okay, we have a vertical tangent line because the slope is undefined. Be very careful with this because what if I said f prime negative 1? Can you find the root of negative 1? Is x equals negative 1 on the graph of square root x though? I don't think so, right? Because the graph of square root x just looks like this, right? X equals negative 1 is not even on the graph of f, so we don't even have to think about it. We shouldn't even consider it. And if they ask us to, they say, hey, it's not even on the domain of f, so we can't find the slope. Okay, just in case they try and trick us, we gotta be critical thinkers. All right, last one. Here we go. See what you can do. I think we're gonna struggle with the setup on this one because now this one says y, right? Kind of annoying a little bit. So that's what I do. Ready? Y prime now, remember, y prime is the derivative of y. This function is called y now. And remember what I said before? You can call something like f or f of x. We can call this y, or we could call this y of t. Yt, because they're using that variable. So if you know that relationship, which they like to try and confuse us sometimes to norm some of these standardized tests, they try and throw this garbage at you. You just got to know how to work with it. Treat it as any other function. Okay, this is y. What variable are we using? T, so it's y of t. You could write like this. And now I think we can have our setup a little bit better. I got a sideways t right here. Yes, it's an x, but it's a sideways t. Y of t plus h, now instead of x plus h, minus y of t all over h. So that'll help us out a little bit. We good right there? First step. Substituting t plus h in for t. This is definitely a common denominator problem. This needs t over t. This needs t plus h over t plus h. And that's what I got. Add the advanced move, multiplied by the reciprocal of h, so 1 over h, right? Okay, if you remember how to do that. Questions so far on this up to this point? We good? Okay, now after that, it's just distribute, combine like terms. I just said t times h times t plus h. That's all I did. I could have left this h over here. This looks awkward though then. Alright, after you combine like terms, you can cancel those h's. Then you can let h go to 0. And there we go, negative 2 over t squared. Questions? Comments? Anybody get it right? 100%? Where are we making mistakes at? The fraction part or what? Now, if you need to, do this. If you're still struggling to get it correct, do this. 2 over t plus h, right? This needs t over t, so I'll go t over t minus 2 over t times this one needs t plus h over t plus h, right? All over h still. So we have 2t over t times t plus h minus 2 times t plus h all over t times t plus h all over h. Okay, so then you can, now we have common denominators. And then multiply by 1 over h. So if you need to take a couple steps to get to this one, that's fine. Write it out.